Yeah, good morning. I am Jain from CDAC Trivandrum. I am working in Power Electronics Group, CDAC Trivandrum. So, past I think around 15 years from there. So, basically, I just introduce our organization, and we have two programs there in CDAC Trivandrum. So, that also in CDAC is a Center for Development of Advanced Computing under the Ministry of Electronics and Information Technology. We have around 11 centers all over in India. So it's basically it's a R&D institutes. So Pune is our headquarters. We have around 3,000 employees are working in all the centers. Out of this 3,000, we have around 1,000 employees are working in CDAC Trivandrum. So our main objective is to undertake the application-oriented R&D electronics applications and promote that electronic industry by the help of that institutes and industries. We have a very good tie-up with all the institutes, basically from IIC Bangalore, IIT Bombay, all the major IITs and NITs, also the part of this our CDAC activities. And we have around 8 subgroups are available in CDAC Trivandrum. Power Electronics Group is one of the core area, a core group in this CDAC Trivandrum, and we have the broadcasting groups for the communication and all things. All of you very well aware about that Dial 112 is one of our flagship projects in the communication group. And hardware design group, we have the India processor is there, Vega 2 processor is there. That is the first processor we have developed in India, that WBG-based. That is our one of the hardware group is developed. And control and instrumentation groups develop this smart farming, smart agriculture, smart farming, smart type developments in the control and instrumentation groups. And strategic electronics group develop this strategic application like underground water, underwater drones application for the Indian Navy and the DRDOs. And health and information groups develop this health related applications for this our societies. And cyber forensic, all of you know, all the cyber activities, that is a 24/7 lab is running in CDAC Trivandrum. So all the cyber activities we are take care of this cyber forensic department. And education, in addition we have some MTech programs and training programs also there. These are the main activities there. And come to the Power Electronics Group. Power Electronics Groups, we have power controls and power and control hardware design and developments, real-time software control designs, and system engineering and operation maintenance and technology transfer and turnkey execution projects are there. Technology base, we have this much of technologies we are developed in these our groups right now. These technologies are by the help of the National Mission on Power Electronics Technology. So that is NAMBET is one of the flagship program is running under the Ministry of MIT. And these are the experts areas in these our developments. These are the main focus area we are reached in these developments. These are the AC drives and DC e-mobilities for AC and DC drives, and high voltage power electronics and DC drives, DC-DC converter, MOSFET, IGBT, PMS, GaN, SiC types. And real-time application, we have the Indian AC developed full spectrum simulator is there by the help of IIT Bombay and IIC Bangalore and CDAC Trivandrum. And we have the microgrids for the rural applications. There is a power congestion is in the rural area that we have providing the microgrids, and power quality centers and digital substations, and smart metering is one of our important projects in this, and STACOM also there for the static compensator for this stabilize the grids. And for the real-time category, real-time control category, there is one of our flagship projects, that is a vehicle control unit for the Indian Railways. That is developed. There is a NAMBET 2 product and complete in NAMBET 3 level. So all of you know the Indian Railways. There is a WAG 9 and WAG 7 and WAG 5 locomotives are available. That control system we are manufactured from industries like ABB, Metha, CGL, AAL and Bell, BHEL, not Bell, BHEL, like that. So that is a earlier technology, 1979 technology, ABB technology. We are currently Indian Railways was used. So that technology we are converted to our own Indianization types. So CEDAC Trivandrum is the leading agency for that technology development. Now the technology was success, and first proto model was commissioned in 2009 in Tughlakabad locomotive shed. After that 2016 second proto model is commissioned, and right now that locomotives are operating in a 5 lakhs kilometer is crossed, and right now around 1500 locomotives are operated by this CEDAC technology. What is that is the importance of this technology, that is why we are taking this technology, this one. So there is a 54 lakhs is the cost for this importing the technology. That is each and every year there is a 175 locomotive, 175 to 200 locomotives are produced from the CLW. So each locomotive requires 54 lakhs for this implementing this vehicle control unit only. So that cost we can cut out to 12 lakhs. That much of savings, money saving is taken care by this technology. That is one of the important things in this developments. And rest of things also, this Indianization of the technology, we can reduce the overall technology cost. These are the R&D facilities we are offering in this our labs. We have technology supporting labs. These are the main softwares and simulation platforms we have in this our center. And we have our own dry heat and thermal cycling requires some thermal chambers and EMA pre-compliance devices are there for our own developments. And totally we have around, it's a small groups, like 120 engineers are working in this power electronics groups. And around right now around 45 development and TOT projects are going, 150 in the last 20 to 25 years, 2025 to 2025. So project leading is mainly from ministry and Department of DST and Railways, DRDO, and user agencies, national and private industries are there. So these are the structures of the NAMBET. NAMBET the funded from the MAITI, and there is a steering committee is there, project review committee is there, nodal center we are operating from CEDAC Trivandrum. I am one of the nodal officer from this NAMBET nodal center. So these are the phase 1, 2, 3, and right now we are coming to the phase 3 level. So each and every institute is eligible for this submitting this proposal to this NAMBET nodal center. So after screening this project subcommittee, they will they will submit to the national steering committee for the final approval. After that, then only we will get the approval and the funding and all the things from the nodal center. That's the procedure. The same thing also EVSS program also going on right now. So electric vehicle subsystems program is going on. So that thing also the same format we are focusing with the institute. Right now around 14 projects are running in the EVSS first phase, and second phase in the project proposal invitation is most probably this month or next month it will announce. So you are I think these people are from industry and academic institutes, so you are also eligible for applying this type of project proposals for the EVSS, especially for the EVSS. These are some products, and I will come to the actually the main the IPT-based contactless charging system. This is one of our projects we are developed in by the help it's a joint project in this CEDAC Trivandrum and VNIT Nagpur. So there is a wireless power transfer for light electric vehicles. These are the main things. I think from wireless power transfer we have we know that there is a two types of power transmitting mechanism is there, that is near field and far field. Near field from millimeters to meters and far field from meters to meters. So there also there is a capacity coupling and inductive coupling also there. So we are taken for the inductive coupling based developments we are carried out in this project developments. And these things there is a comparative chart for this 0.01 meter to 10 meter things we have we have segregated in low power and tightly coupled and medium power and high power things from 0.01 kilowatt to 10 kilowatt range. So apart from this, middle range, medium power is the most efficient for this our own applications. That is the consumer electronics, cooker, TV, fridge, refrigerator, washing machine, CPU, and those things, electric vehicles. Also, we can use this medium power wireless power transfer system, and it will provide up to 90% of efficiency. This is a comparative chart, and if suppose we go for the higher power, that will be the efficiency will reduce to 60 to 80%, and it is up to 50 kilowatt it is possible. And in the low power WPT applications, there is a 1 centimeter to 1 meter, that is for the mobile phones, and so applications are, I will explain the later. So those type of applications we are coming to the this low power wireless power transfer system. And wireless power transfer schemes, these are the basic schemes. There is a compensatory topology is required, and resonance structure is required, misalignment, EMA diagrams, and control and others. These are the main part of these developments. And this compensatory topology, we have basic and hybrid type topologies there, series and series parallel series and parallel. And right now we are taken for our development, this is 1.5 kilowatt wireless power transfer for this light electric vehicles, and 5 kilowatt for the same thing. And we are taken this compensation topology is parallel series type. And here it is resonance structure, we are taken for flat planar coils and transferring distance and 3D coils, quality of factor, track and rail efficiency effect. These are the resonance structure we are using. And misalignment also, one of the factor for the angular is coaxial is horizontal is and circular is there. So those are the other major challenges in this in this development. And EMI diagnosis, all of you know that we are the power electronics people, we know the EMI challenges is one of the factor in the all the developments. So that things also we are taking care with shielding methods, active shielding and passive shielding and other shielding methods is there. So we are take care in this our development, we are take care for the passive shielding. And these are the second type of coupling technology for the wireless power transfer, as I discussed earlier. That is the capacity model. That is there is a transmitting coil and receiving coil in the space, air gap is there. That is a capacity model coupling technology we are using for this wireless power transfer techniques. And this is the basic resonance circuits in this our developments. These are the inputs we are taken care from this the rectifier unit. There is a input volt, there is a AC current is converted to DC, and again converted to high frequency inverter. There is a for this voltage level upping, and it is come to the, there is a high frequency, that is 80 to 90 or 95 kilohertz range of frequency we are using for this type of developments. So that is by the help of resonance circuit, compensation circuit, and we are transferring that power to receiving coil, and receiving coil receive the power and rectify to our own voltage level. That is our requirement, our development required is that is 48 volt, so that we can feed to our battery. These are the electric vehicle charging application. All of you know about that. There is the first thing is the conductive charging. We know we have the electric vehicles and all the things. The conductive charging is a wired charging. We wired all the vehicles to this particular slow charger or fast charger systems, and this is the static charging system, that is wireless contactless charging. We park the vehicle from anywhere itself. Suppose we are using the round type coils, we can park the vehicle from this direction, we can park from this direction, any direction. So the misalignment will that is reducing their misalignment things, and we can get the maximum accuracy, and we will get the maximum efficiency from these things. And this is the inductive charging, that is a dynamic charging system. We place the coils in the transmitting coils in the roads or particular track. So the vehicle will move in the over the coils that will automatically charge the battery inside the vehicle, and vehicle running from it's a particular direction to particular point to particular point. That is with the autonomous applications and biomedical implants. This is another focus area for this wireless power transfer. And the roadways and lighting, etc. We are using these dynamic charging systems. And also in the drone systems also we are using this wireless power transfer for this dynamic charging system, as well as the wireless charging system also for drone applications. And this I am already, I think, this wireless charging, and this is the comparison of this wireless charging and conductive charging. This one we will provide around, it's a auto charging system, very simple and elegant and low rate of wear of and tear of charging pads, and minimum risk of reduction, and ability of stationary as well as dynamic charging. And if we can compare to the conductive charging, there is a manually plugged into the charging cable to our vehicle. That is one of the things. It's a manual. All of you know about that. That plug, weight of that plug is very huge. I think suppose it's more than 10 to 15 kg weight is there for this connecting this thing, and high rate of wear and tear due to the high usage of the moving cables, and portable risk of reduction, and only stationary charging is required possible in this conductive systems. And it's also they will offer the higher efficiency. It's a direct wire to wire connection. Here its efficiency is less than in and around 90% is there. Requires high control for parking accuracy is adopted in this technology. This is a basic scheme I am already explained. I think actually these are the capacitive and resonance. These are the three things. We are capacitive, inductive, and radiative. These are the things we are using in this technology. I think this one is again repeating some slides in the coupling of the capacitive wireless charging system. We are explaining this transmitting side and this coupling capacitor. There is forming by the help of these things, and this is the receiving side. Come to the coil design. There is a 2-3 types coils are there. There is a first one is the circular type coil. This I am already explained. Like there is a misalignment is we can take care from this maximum efficiency we will get from this circular type design. And this is a double DQ pad and solenoid type and DDQ pad and bipolar pad. This one is a particular suppose particular fixing case is there, so we can use this one. And mobile also, mobile we can place in a car in a particular square area. So that area we can provide this type of architecture that is very useful for this one. And capacitive, and that is a circular type piece we can use for the normally for this automotive applications. This is our first design in this project. The coil, anyway we required the transmitting and receiving coil. This transmitting coil, receiving coil, and we analyzed this flux density of this coils. These are the transmitting coils has more turns and receiving coils has less turns. So what is the flux density? Here the transmitting coil and receiving coils within the same turns, whatever the flux density we can analyze by the help of ANSYS software and simulation, simulate all the things, and then we can go for the final productions. These are the non-conductive material we can put in the back side, and about that there is a ferrite beads is there, and aluminum sheets for the passive conductions, and we can mold these things. That is a procedure for manufacturing this coil. And legs wire we are using for this coil, you know, this frequency is very high, 80 to 90 kilohertz frequency range we are using for these developments. So legs wire we are using, and these are the coil misalignment we are discussing. So these are the transmitting coil and receiving coil by the help of these ANSYS tools. There is this is a 50% misalignment. That's a 50% efficiency. We will get this much of misalignment. That means the field is come to this area, so we will get only 50% efficiency from this alignment. Here we will get around 90% efficiency. That is the coil design factors and mutual inductance with misalignment. And these are some test results for this our developments. And finally, we are implemented these products in a three-wheeler auto rickshaw. So that is our requirement is that 48 volt is our required battery voltage capacity, and these are the transmitter and receiver coil number of turns is required, and outer diameter of this this coil size and inner diameter is there, and those are the parameters we are things. And these are the before going to this our final implementation, we are developed this technology in the lab level. These are the transmitting coil, these are the receiving coil, and this our controlling units we are kept in a separate unit. We are tested, and these are the one of the major thing in this developments. We have there are two types of compensation circuit is required for these things. So first we can take the series connection, and second is the parallel series compensation circuit is adopting in this developments. So suppose we are come to this series compensator circuit, that voltage stress and transmitting side capacitor, it is very high. That is size of the capacitor very high, and voltage stress on the transmitting coil also very high, and the current we can come into the within the limit, and the current stress on the transmitting coil shielding technology we want to select for this our particular applications. So these are without chassis and with chassis, passive shielding, active shielding. So from this passive shielding we will get the maximum output from our design, and so we can choose this passive shielding. These are the active shielding, and these are the with chassis shielding is there. So finally we will come to the transmitting coil and receiving coil come in the same number of turns. So this is the developments from the bottom level. So finally we are decided that we require both the coils in a same number of turns by the help of this glitch wire and this all the shieldings and ferrite bead size and all the things we can calculate from this data. So we are manufactured, these are some test experimental results with the shielding technology, and these are the final products we are manufactured here. So this is our system controls, that is a converter and inverter, high frequency things. Boost converter is the for this boosting, and HPH inverter and compensation circuit. Those things we are implemented here, and these are the final products of this coil. Coil we after the manufacturing, after by the help of industry. Anyway, we are the that R&D peoples. We know the final industry product. We don't have the that much of idea. So, but the industry peoples know the quality of that product at TRL level, and all the things take care by the industry people. That's why the coil manufacturing, we have a high-rise transformer is there in Nagpur. So by the help of that peoples, we are manufactured that coils in this form. It comes around 20 kg, around 20 kg weight for one coil, and one coil normally we are placing the transmitting coil in the platform, and this receiving coil in the vehicle side. So our required developments for this things is 1.5 kilowatt 30 ampere current we are drawn from this transmitting through this coil for 48 volt applications, and these are the three-wheeler. Sorry, these are the three-wheeler we are implemented this technology, and we are make a permanent platform for this particular things. So we can place the three-wheeler like that in the particular platform, and the transmitting coil and receiving coil comes into the same directions, and there is no misalignment. Almost 90% efficiency we will get from these things. This is the transmitting coil, and receiving coil we place here. This is not the final coil, we are not put in this here. So these photographs are taken from before reaching these coils. So these are the test results from test photographs for this particular developments. These are the some subcomponents we are developed for these things. And these are the some test results from these developments. And come to this wireless power transfer, one of the application is medical applications. This is very interesting things. There is a LVAD, left ventricular assistant device is required for after 70 or 60 where there is some blood circulation is reducing. So we need some LVAD system is required for this all the human beings. So right now the LVAD system is there, and the battery is we can put in the outside the body. There is a by using this wired system we can use. So these things are incorporated in this like just an inner wear of the human. So this thing we can convert it to wireless power transfer. The battery we can put it inside, like we know the pacemaker we are putting the battery inside. So pacemaker also there is a some limitation for 8 to 10 years battery life is there. So after that we want to replace that things. So these things we are using for this wireless charger technology. So we can put the receiving coil inside this LVAD system, and transmitting coil we can put in the by the chair or your innerwear, your bed, whatever it is we can put the transmitting coil. These are the just architecture for the LVAD. There is a pre-regulator, that is a power source, and DC to AC rectifier, and impedance matching, and resonance circuit. These are the outer part of this transmitting coil. These are the receiving side. Inside the human body we can just there is a LVAD system, battery is there, rectifier and impedance matching. There is a power receiving from outside, and we have providing a monitoring system for and sensing control. What is the status of the battery capacity and all things. Suppose the battery is very low, we cannot sustain the human. And another application is the system with normal supply and LVDC supplies. There is a right now we know the LVDC is one of the major things in this our day-to-day life. So all of you using our household tube lights, fans, everything is in the very low voltage, but we are taking from 230 volt, and there is a conversion loss, very huge conversion loss also there. So appliance comes in the 12 volt or 24 volt or 48 volt levels. So and the power consuming also reducing by the help of this LVDC technology. There also we can use this wireless power transfer technology. There is a LVDC DC AC high frequency converter is there, and their compensation circuit, and we can again transmitting the power from one source transmitting to receiving side. Receiving side we receive, and again we can convert it to AC DC converter, DC DC converter. For the level of the voltage we can reduce by the converter. And here also in grid tied system also we can adopt the system. There is a renewable energy source, there is a grid is there. So and battery storage also there. So this voltage we can transferring through this technology. And what are the advantage? There is a, if it is AC load is required, we can transfer the AC, convert it to AC and DC to AC, and we can put directly to DC loads to DC voltage by the help of this architecture. And this is another applications we are adopting in this desktop system, IPT system. So there is a this is a normal thing we are using. We know our working table like this. All the wires are there for connecting from CPU to PC, then the monitor and keyboard and all things. Suppose we want to convert these all the systems like that. There is a wired wireless power transfer. We can provide the power from this particular table and particular system. That is the advantage of this by using this system. And only the this things, there is a CPU is the main system of our computer and all things. We can provide a particular slot for this this misalignment is reduced by this CPU system. We can provide the particular slots, and other things we can it is easily movable and all the things. These are the battery systems and our scheme of these implementations. And this is IPT based UPS system, how it is working. These systems are available there. This same thing from the sending end and receiving end. So, but we can use this system in a different applications. That is the important thing for this wireless power architecture. And these are the challenges and degree of the difficulties. We are higher efficiency exposed the advantage of topology of innovation, which provides low device cost losses with device losses, and coupling circuit that is a new development for the magnetic area, and misalignment is one of the things, and shielding, skin effect, and coil manufacturing, and there is a mechanical structure is required for this particular coil development, and designs of magnetics and earthing also one of the important things, but we have some protections from protections and safety aspects. This wireless power transfer system is the very adaptive for this new developments. And these are the my presentation for this system. I think if you have any queries regarding these things, please ask. Yeah, that is 15 centimeter. 15 centimeter, 15. 15 centimeter is that is sufficient for this automotive sector. Right now, I think 200 centimeter is the boot, that is length of gap between roads, and that is for the EcoSport and SUV vehicles. Sedan vehicles, that much of distance is not coming.
Did you have communication between the vehicle and your, because you have only one control, right? Primary side switches.
Yeah.
The only control. So did you have any communication?
Yeah, we have the communication.
Like,
No, that is a Bluetooth communication and Wi-Fi communication we are using. Bluetooth and Wi-Fi communications. That RF and all things, again we are creating some distortions and things, EMI, EMC, EMI problems we are facing. So that is the development aspects. Right now we have a 2-3 industries. One is the Belrise from Pune, and Tata Power and Mahindra also. First level discussion is over for this technology developments. That is 80 to 90 kilohertz. That is that nothing is.
Sir, I have a question.
Yeah.
Are commercially available wireless chargers available for 4-wheelers? I saw 3-wheelers. 3-wheelers here.
Yeah, it's actually we are the technology developer. We are the people from we are developing only the technology right now. That's why I'm telling you. We are first level discussion is over with Tata Power and Mahindra and Belrise Pune. So these people are the industry people's manufactured, taken our technology and manufactured in the multiple level.
Thank
for
you.
the 3-wheeler. Right now we are developing for the 3-wheeler applications. For 1.5 kilowatt to 5 kilowatt is sufficient for this. Yes, sir.
So,
Capacity wireless, I think we have some challenges. That is one of the challenges, capacity things. And this technology is just upcoming. It's a development area time. So all the peoples are taking. Where is the challenge is very less, then we can go for the developments. Otherwise, capacity is also good, but there's the challenges are there. That's the truth.
so between here, between the fixed wireless charging versus inductive charging, so do you foresee that same receiver would work, or we have to make some design changes where you have to switch between the inductive charging as well as you need to have 2 receivers in the car, for example? If a car goes to a charging spot and then charges versus on the road charging in the future, where you have patches of roads where they wirelessly charge the car while they are on the move.
Yeah, that is right now there is a news is France, they are introducing this dynamic charging, that is called
Correct.
dynamic charging. It's a track they are providing. In the continuous way that is not required, that the coil alignment is not required for the continuous way. Suppose we have the battery power is there. So our aim is to move from one end to other end, and by the help of we have battery power is there. So in addition we can take some power to charge the battery also. That in that case some misalignment and some things we can compensate by the dynamic charging.
But the receiver would be the same?
The receiver will receive same.
Okay.
That is some other some communication controls are there. Suppose that is the software part.
Okay.
And the same thing we can use for the drone applications also. Suppose drones carrying their own some limitation is there, some battery capacity of the things there. So we can charge the drones by the help of all the some other drones. For right now it's for the Indian Navy and Indian Army, they are using the drones by the wireless power transfer things. Developments also going on.
Thank you.
That is our requirement. What is our load requirement? So based on the load requirement, we can design the voltage. Yeah, it's a high frequency, high voltage boosting is required. High voltage is required.
Sir,
Yes.
sir, you mentioned the frequency. Sir also asked about the frequency. Is
Yeah.
it based on some standard or is it?
Yeah, it's a safety, human safety also one of the factor in this chosen this much of frequency level. There is suppose we are kept in the power transfer level by using this frequency 80 to 90 kilohertz range. We can put the hand there. There is nothing is happened. Suppose if it is above 100 hertz, something will happen. That is not sure. So that is why near field and far field. The next one is far field. That distance and frequency will increase. That is come to the other far field category. Yeah.
Sir, did you try any different specific patterns? I mean, in terms of pattern design of the coil. So any R&D on that? Like a particular pattern is more efficient than, let's say, a typical circular pattern.
Actually, the circular pattern is more efficient.
Okay.
That's why I'm telling you that iPhones are using the circular pattern. There is a possibility. There is a possibility for the iPhones is in the square shape. All the mobile phones in the square shape. So we have the possibility to make a rectangle type. But they are using circular thing. That is the only thing for the misalignment things. And that's one of the main advantage for this developments. I think you are the industry peoples and institutes peoples. So you are the developer for this futuristic that is application like LWAD and all the things, and this drone applications, vehicle applications. We are just developing this technology only. Okay, once again, thank you for your listening and all this. Thank you.